Hello, everyone. Thank you so much for joining us today for our second in a series of three webinars convened by UNODA and UNIDIR on the technological, military, and legal aspects of emerging technologies in the area of lethal autonomous weapon systems. Just as a recap, our overall aim with these webinars is to provide analysis on issues under consideration within the group of governmental experts that would benefit from additional clarification or review. The first webinar convened yesterday by UNIDIR provided a good foundation on the current state of technology, what is possible, the capabilities and limitations of AI systems, the importance of including data in our discussions, and possible common approaches for the testing and evaluation and performance of reliability of AI systems. Today, we'll be discussing military aspects, which we will break into two segments. And we will be following a slightly different format from yesterday. Each of our two panels will start with expert presentations before we open up the floor for questions and discussions. And hopefully our panelists in their presentations will be able to speak to all the questions that were provided to us in advance, but we'll also have an opportunity to pick up on those that didn't get addressed as we go on. Like with yesterday, anybody who wishes to pose questions to the panel can do so by directing those to us in the chat. And we will feed those into the discussions as we go. And then finally, I would also like to encourage presenters from yesterday in particular to actively engage in the discussion as well if they have points that they wish to contribute as they go along. With that introduction, we'll move directly into our first segment, which will address security considerations. Now, while there's been a considerable focus within the GGE on humanitarian, human rights, and ethical implications of lethal autonomous weapon systems, there's been significantly less time devoted to implications for peace and security. As these implications would be quite important for the design of any normative and operational framework, we will be spending our first hour today in further exploring dimensions that could benefit from some deeper reflection. As we heard yesterday, the world may still be far away from the day where current technology supports fully autonomous lethal weapons that can meet sufficient standards in terms of reliability, predictability, explainability to ensuring compliance with international humanitarian law and ethical norms. But using technology available today, some actors may nonetheless seek to build lethal autonomous weapons without concern for such standards. And both of those possible outcomes seem quite relevant for our discussion today. So in connection with security implications, the GGE so far has focused on what I think we can identify as two axes of concern, both related to possible risk that lethal autonomous weapon systems could alter the incentive of decision makers to consider when the use of force is appropriate. The first axis relates to decisions to carry out an attack. At the 2019 session of the GGE, several delegations argued that the use of lethal autonomous weapon systems would lower risks to one's own armed forces and therefore result in decision makers authorizing the use of force in situation where this risk would have otherwise been an inhibiting factor. According to this argument, it follows that an impact of the introduction of this technology on a broader scale would be to lower thresholds for the use of force in such certain situations, for instance, at a time of crisis or heightened tensions. A second and related axis relates to the risk of unintended escalation. I think perspectives on this nature of the risk were really very well captured in the documents from the 2019 session. So I think this is certainly a dynamic that should be better explored. And then there is finally a separate concern which relates to the possibility of laws to contribute to arms competition and proliferation, and in particular implications that would arise from non-state actors acquiring autonomous weapons. And so again, precise convergences on all these concerns haven't yet been reached, but I think they're very relevant, especially in any arms control context. And so we will look forward to our two panelists today, providing us with a little bit more sort of perspective on these various areas. And so first, I would pleased to invite Vadim Kozyulin from the PRI Center to deliver a presentation to the group. Vadim, you have the floor. Thank you.
Thank you so much for giving me the opportunity to speak to your distinguished audience. Can I make a presentation? I have some slides. I'm not sure that I see how I can use them. Probably I cannot. No way, seems to me. Okay, then I'll do without it.
Just a moment. We are told that there is an ability. You should be able to access a share button, which is visible.
Share, yes. Oh, okay, yeah. Yeah, possible. Perfect.
Okay, good. We can see it.
Okay. So my name is Vadim Kozyulin. I'm a research fellow of Russian Diplomatic Academy and program director of Peer Center. Also, I'm a participant of IPRO group, which will hold our workshop #1 just after we finish our session today. So I just want to remind those who plan to take part in it, please don't miss it. So according to statistics, there are 31 conflicts in the world today. However, there are rather few wars between relatively equal adversaries with approximately equal modern capabilities. And one of such conflicts on the territory of the former Soviet Union is the conflict in Nagorno-Karabakh. In late September 2020, heavy fighting broke out along the borders of Nagorno-Karabakh, and it's the first most serious escalation since 2016. According to the official information, more than 1,000 soldiers and civilians have been killed, with hundreds more wounded on both sides. Though in October 22nd, President Putin mentioned the figure of 5,000 victims of the conflict. Both sides are now talking about multiple violations of IHL. Amnesty International, Halotrust, Human Rights Watch, and Kazakhstan Experts Center, Fact Check KZ experts have verified use of the following weapons against civilian installation: artillery systems, 300mm Smerch rockets, and cluster munitions. These cases are recorded, and organizations prepare their reports that will be soon presented to public. At the same time, every day we can see almost live application of unmanned combat systems. Most likely those are UAVs and suicide drones, loitering munitions. Loitering munitions are not yet recognized as lethal autonomous weapon systems, since they are likely remotely controlled by operators. However, we can't be sure that they are really remotely operated, and it's quite possible that these loitering munitions might be completely autonomous. In any case, we can call them, at least we can call them, lethal autonomous weapon systems precursors. At the same time, it can be noted that nobody talks about violation of IHL when those high-tech weapons of the 21st century or precursors of laws are used. These are expensive, high-precision weapons, and they deliver pinpoint strikes. This is how they differ from previous generations of weapons that were developed with the aim to inflict a maximum damage. Historically, the military has always sought to produce the most destructive weapons. Today's trend is different, it's high precision. The laws correspond to this trend. The greatest destruction and victims in Karabakh are caused not by laws, but by MLRC, multi-launcher rocket systems, and artillery. In this sense, laws represent an example of proper enforcement of the IHL. Thus, we see that the 21st century weapons are able to comply with the IHL, at least until ground-based autonomous drones enter the battlefield. They will be trained to fight people, not just armored vehicles. And in any case, if today the laws is not yet perfect enough to comply with the provisions of the IHL, then tomorrow they will definitely learn this and will comply with international law much better than human soldiers. Still, I always point out that combat robots, what combat robots cannot do, they will have no idea of human dignity, and therefore they will not be able to adhere to Martin's clause and comply with, quote, laws of humanity and requirements of the public consciousness. The human dignity is the real value to preserve. Therefore, I support the idea that laws should be banned or at least severely restricted. However, it seems to me that this is not possible for a number of political and purely technical reasons. First, trust. We see how the arms control system is disintegrating under real and far-fetched pretexts today. New agreements do not appear in place of those that disappear. Once I asked a Russian military a question. What is the reason that you do not support the ban of laws? He responded by asking, can we trust the United States not to develop such weapons in secret? Indeed, today the world has returned to the time of suspicion, distrust, and fakes. Trust is in short supply. Second, verification. Verification measures used to help to reach agreements in the absence of trust in the past. But verification of laws is technically difficult or even impossible for reasons of secrecy, security, and so on. On the internet, we see many videos showing the use of high-precision ammunition. It means that the operators make a video recording, which is likely to be stored in the archives of the Ministry of Defense. Theoretically, if necessary, it's possible to study the history of a specific case of use of the ammunition. It may be possible to consider entering into an international agreement to provide these types of video recording in certain cases. Such materials could also serve as confirmation that the operator controlled the use of the autonomous weapon. So third, limited radio communication. However, there are purely technical factors that force the militaries to develop completely autonomous modes of laws use. This is limited radio communication. Tests of remotely controlled ground robots in a number of countries have shown that the effective range of radio communication between an operator and a drone does not exceed 2 or 5 kilometers. In autonomous mode, the ground robots will be able to operate at a distance of up to 500 kilometers. And 4, electronic warfare. Electronic warfare is always used in modern warfare. This area is currently experiencing a noticeable upturn. The military doesn't have an answer to the question how to ensure effectiveness of human control over a remotely controlled combat robot in the case of electronic warfare. What should combat drone do if it loses contact with the operator? Possible scenarios are as follows: return to the base, remain in place, go autonomous mode. For military, this is a task which is this is a question with an absolutely clear answer. I will be very grateful to anyone who offers a different response. For these reasons, a complete ban of laws seems impossible to me, but it seems that we are close to signing a political declaration where participants commit to adhere to certain principles, in particular those that have been already approved by the GGE. Also, it seems to me that the use of AI in military affairs carries some more risks. First, outsourcing command control computer and communication to artificial intelligence. Intelligence, surveillance, and reconnaissance, ISR. It leads to the removal of humans from the real control of the situation. Time factor. Military systems speed up events and reduce the time for human judgment. Humans will have not enough time to critically evaluate the information received. Also, the factor of automation of decision-making process. Machines will do the information collection, processing, and analysis, preparation of scenarios, and distribution of functions. A man can only hope that the correct algorithms were used by the machine. I also want to finish where I started. There are 31 conflicts in the world today. As a rule, these are conflicts with terrorists, drug traffickers, political opposition, separatists, and insurgents. Some conflicts are often based on ethnic or religious differences. Sometimes there are fights for power, territories, and mineral resources, and less often for ideological reasons. In other words, in many cases, these are internal conflicts. So far, we do not see any autonomous systems that would be intended for law enforcement agencies for internal use. Still, we can expect that in future there will be systems that will be able to resolve such conflicts, internal conflicts, much faster and with fewer victims. We can probably expect appearance of non-lethal autonomous systems created for police purposes. Internal conflicts will be short, and weak side will have no chance to win. The one who has resources, finances, and external sponsors to buy non-lethal weapons will win. For some political regimes, the use of laws, non-lethal autonomous weapon systems, against their own population will allow them to retain power in a situation when neither the army nor the police are ready to protect them. That was my last point. Thank you for your attention.
Okay, thank you, Vadim, for your presentation. See that there will be some interesting follow-up as we go, but before we get into that phase, I would like to move on to our next speaker, who's Trisha Ray from the Observer Research Foundation. Trisha, you have the floor. Thank you.
Thank you, and thank you also to Unidor and UNIDO for organizing this important series and for inviting me to be a part of it. I have a handful of questions and very little time, so I'll start with some use cases. I'll go into a few contextual scenarios, and finally, to really feed the nightmare fuel, I'll talk about proliferation risks, especially those to non-state actors. So starting with use cases, if we look at some of the statements and documents put out by various countries, there are a couple of common threads in terms of use cases. The first is autonomous weapons as a force multiplier. And this is an especially compelling use case for smaller countries with rapidly declining young or military active populations, or if they have vast hostile border terrains to patrol. The second set of use cases revolves around reducing human casualty, both in terms of reduced boots on the ground and backed by the assumption, and the team also alluded to this, backed by the assumption that improved targeting will be possible, reducing the deaths of innocent non-combatants. And the final set of functions revolves around various patrol functions, especially in the maritime realm, which essentially mean operationalizing the defensive depth concept for a lot of countries. Now, before I dive into the scenarios, I do want to say that the laws debates really need to move away from this tendency to group global souths and global north actors into homogeneous blobs. There's considerable overlap between the two, and there's also a lot of differences between amongst these groups in terms of the security environment they operate in terms of technical capabilities, and in terms of the kinds of militarized conflicts that they are involved in. So let me explain that. If we take, for example, the case of border conflicts, regional and bilateral dynamics vary wildly around the world. And we've already seen some cases of low-level autonomous units being deployed for border patrol functions. There was infamously South Korea's SGRA-1 SIPRI robot, which had a human on-the-loop mode when it was first deployed and generated quite a bit of international controversy. And then the US Border Patrol is also testing autonomous drones for use at the US-Mexico border, presumably only for surveillance functions. Then we have, again, in the context of border security, there are countries that are engaged in active and persistent border conflicts that frequently flare up into skirmishes and clashes. In the Indian context, for instance, this year, there was the clash between Indian and Chinese border forces at Galwan, which has precipitated into a massive diplomatic and economic conflict between the two nations. Adding to this is, in many contexts, the involvement of third-party nations, either through alliance arrangements and treaties, which add another level of complexity to these conflicts. For instance, if we look at North-South Korea border conflict, it's unlikely to remain bilateral. And this context is also very different from the one I illustrated earlier, the India-China context, because the DMZ is also a lot more heavily surveilled, heavily militarized, and a smaller area to patrol. And then finally, adding to all of these factors is the fact that there are duos and trios in the region where one or more are nuclear weapon states. And this could result in all sorts of horror story scenarios arising simply from escalation. There are already a number of worrying trends regarding the robustness of a nuclear firebreak between several of these countries. And I have not even really touched upon the realm of autonomous nuclear defense or AI-aided nuclear decision making. Moving on to proliferation risk. Now, this is where the governance of autonomous weapon systems can rapidly intrude into a country's broader economic ambitions relating to emerging technologies, industry, AI especially. And here the lack of clarity on the object of governance really comes into play. This was something that was brought up at the technical aspects webinar yesterday as well. And so while export control regimes can stem the flow, a lot of component technologies, which are fairly banal, sensor fusion, computer vision, image recognition, facial recognition, all of this would be much harder to govern. Now, to all of this, we add the role of non-state actors, proliferation actors. This could take a few forms. One is if a non-state actor steals or otherwise acquires autonomous weapons units or systems. If we are to build a governance framework, it would have to ensure that countries that possess these systems not only account for the physical security of the units, the facilities in which they're stored, but also robust cybersecurity measures, because stopgapping is not going to be enough. You also need to inculcate basic cyber hygiene practices amongst the operators, because the insider threat is something a lot of organizations don't often account for, and building the concept of resilience, as in what do you do if you lose control of a unit, especially since there are already several examples out there of adversarial AI or spoofing that can easily thwart a lot of these systems. These elements of security would need to be integrated into any governance framework. Then another proliferation example, which would be perhaps a little more difficult to govern, would be if a state equips proxies such as insurgent or terrorist groups with autonomous weapons systems. This may seem unlikely at present, but in the long term, we may see it become more feasible as these systems become cheaper. And this would require, of course, that the suppliers of these systems ensure that the people, the countries or actors they're doing business with have in place necessary safeguards or have proven that they're trustworthy partners. Again, this is a little difficult to account for. The US did put across, for instance, a drone governance framework, but two very important actors were missing from it, China being one. And if you don't have the other biggest drone suppliers within your framework of ethics, that's not a very effective framework. And a third, and this actually plays off of something that was brought up at yesterday's webinar, is that you can Frankenstein some of these units by just acquiring component tech and building something that's unsafe but somewhat effective. And again, in this context, I want to bring up this problem that I like to call the autonomous little green men. A lot of people who would have followed the Russian invasion of Crimea in 2014 would remember that in March 2014, hundreds of mysterious gunmen turned up in the streets of Crimea and aided pro-Russian forces. And while Russia initially denied their existence, Putin admitted a year later that they were indeed Russian forces. And the rationale behind this tactic is pretty compelling, because you aid your pro-Russian forces while generating uncertainty about Russian involvement. And this ties into the proliferation question, because states can claim that they have lost control of individual units or they've gone rogue to dodge responsibility. And even a single unit can do a fair bit of damage, as we've seen in the case of September 2019, the attack on Saudi Aramco installations. I'll stop there, but I'll be happy to expand on my comments later.
Okay, thank you, Trisha. I think that was a very useful overview. You've hit on a number of the key questions already. And so we'll have about 25 minutes now for questions and answers. So I am struck by kind of both your presentations. And I think what was very useful is hearing some of the very concrete examples of existing technologies that are sort of moving in the direction of autonomy, and what some of the specific use cases would be. What is of interest, not just from one perspective of one region or situation, but also looking across regions as well, and that kind of point of differing threat perceptions and regional situations is quite an important one. And so I think the first question I'd like to kind of hear a little bit more reflection on is of these different emerging technologies and capabilities. What are you most concerned about in terms of those that would be the most destabilizing, and in what kind of scenarios? Can you point to specific capabilities already? Would be interested in both of your views on that. Who wants to start?
Is it a question to me? Or?
It's a question to both of you. So anyone who wishes to go, you have the floor.
Okay, if you permit, I suppose that today we don't see the most dangerous lethal autonomous weapons. They are in production yet, and probably they will be ground-based. The technologies are not perfect at the moment, but works are in progress, and I know that many companies, many manufacturers nowadays invest a lot of funds to produce ground-based weapons, which will be operated remotely, but most probably they will have autonomous mode by the reason which I already mentioned. Remote control provides possibility to operate them at a distance of up to 5 kilometers only. The communication is very unstable, and testing which took place in some countries show plenty of deficiencies of remote control. So it will be autonomous mode by several other reasons which I mentioned. And of course, ground-based vehicles will have to do with the civil population, will have to fight in quite complicated environment in cities. Engineers are working on the mode of operating in urban environment. They train machines, drones, to differ combatants and civilians. Most probably, it will be effective to some extent, but the city environment does not will not be a proper place to use autonomous weapons. And modern conflicts will not allow to avoid this kind of warfare, or urban warfare. So I guess that it might be quite dangerous development as far as those weapons will work in swarms, which means that operator will not be able to control properly each of them. They will divide their functions, and the environment will be complicated because of electronic warfare. So some missions conveyed to the drone from the operator might not come at proper time, or the situation will change, but the jamming will stop the communication line, and the combat vehicle will continue the mission, which has to be stopped already. So some complicated situation will take place. Probably another dangerous field for autonomous weapons might be drones for missile defense. I remember one project which was examined in the United States. A drone had to carry anti-ballistic missiles, rockets, along the border of North Korea. Again, most probably there might be a kind of autonomous mode implemented for the sake of saving time. Ballistic missiles have to be countermeasured at the very beginning, at the first stage. So probably the time limit will be rather short, and there might be no time for humans to take decisions. So this patrol might engage autonomously. So when we talk about nuclear weapons, when we talk about missiles, it's always dangerous and it's always very provocative, and it might ignite regional or even global conflict. Thank you.
Okay, thank you, Vadim. Trisha, did you want to come in on this question?
Yes, the most worrying part about these technologies is that a lot of the component tech is far from perfect. We can't even yet make autonomous cars that don't run over people. And facial recognition tech is notoriously imperfect as well. We have the case of the Sri Lankan student, I think from Brown University, who was misidentified as one of the perpetrators of the Sri Lankan attacks in 2019. So the component tech is still far from really working well, and so that's just a premature rollout of any of these systems based on this imperfect tech would be an issue. The second worrying realm is, of course, I briefly mentioned that there is some consideration in various countries on integrating AI into nuclear defense and nuclear decision making, which is, again, not ideal, especially in terms of strategic stability. In some conversations, just the presence of the comprehensive ISR capabilities required to make such a system possible is enough to generate instability in a nuclear dyad. These are the two areas I'd like to bring up in response to this question.
All right, thanks. So a follow-on question posed to us, and in terms of systems that are kind of in deployment or near deployment that have an automated mode, do you see a significant difference in terms of the implications as more AI is introduced into these systems like machine learning? Does that qualitatively change the kind of risk and the use cases that you have looked at, Trisha?
You broke off a bit in the middle. Could you repeat that?
Right. The question is, and use cases that you have examined that might involve existing systems that operate in an automated mode with the human on the loop. Can you kind of describe what you see in terms of the impacts of different kinds of AI technology like machine learning is introduced? How do you feel that affects the risks?
Yeah, so some of the issues with human on the loop system is something that Vadim has also brought up, which is that human on the loop essentially means that an operator can intervene to stop a function being carried out, but they're not in control through the entire process, which can be difficult in complicated scenarios such as a border skirmish or an urban theater conflict. Then in terms of, let's see. Yeah, I think that's the issue with Multiplier, which is simply that because a lot of these complex scenarios are complex, that human control, and this is something that the GDE is also agreed upon is essential at all stages of development and deployment of autonomous weapons.
Okay, thank you. So I think the next area that I think I'd like to explore is really the dynamic of arms racing and arms competition. And so we would tend to look at this in terms of the reaction that one actor has to the acquisition of a certain capability by another actor. And does that motivate them to acquire a comparable or an offsetting capability in response to a rival? And so when it comes to autonomous weapon systems, would like to get your views just in general terms as to if you see that there's sort of a particular or even a unique potential that lethal autonomous weapon systems could play, or are there certain particular characteristics or capabilities in military missions that you feel that the introduction of autonomy would sort of be particularly lending itself towards arms racing type of a dynamic?
Can I?
Yes, Vadim, go ahead.
Okay. First of all, what I noticed recently, we know that military expenses are growing globally. Countries spend more and more nowadays, not all countries, but many. And the total amount of funds for weapons is permanently increasing. But the pace of R&D, military R&D expenses increases much faster than general military expenditures. For example, United States spent something like 90 billion US dollars per year on military research and development only. So it signals me that Pentagon knows that they have to invest in military hardware, but it's better to invest in future military hardware, in future weapons, in future military systems. It's not only weapons, it's a network, it's network-centric warfare, so which means communication, which means sensors, platforms, clouds for calculation, for transmission of software, for updates of military software over the globe, and so on. And of course, autonomy, it's a key element of future combat missions. We think that today we have a weak AI, so that gives us a reason to say that autonomous weapons will not be reliable, will be imperfect, and probably they are, probably for some time they will be less perfect than humans, but in the longer run, we can expect much better weapons, much more precise weapons, much smarter smart munitions. So we should think about it. If we talk about IHL violation, yes, I agree to at present time they will violate IHL, but in longer distance, at a longer distance, they will not. They will be precise, they will be smart, and they will pose more threats to those who do not have. So those who have will definitely win, and that's the problem for those who do not have today. Those who have no funds, no technologies, they will always lose in future combats. And that's why, if we talk about arms race, yes, it's going on already. It develops, and it's not that much visible just because it goes on in labs and in design bureaus. Soon we'll have all that. Those technologies will suffers in great numbers of cheap and smart autonomous weapons.
Okay, thank you, Vadim. Trisha, did you want to come on to this question, arms racing?
Sure, yes, I would echo Vadim that an arms racing dynamic is possible, but given that if we just look at the current state of research and investment into AI, machine learning, and robotics, it's dominated by 2 or 3 countries and a handful of other major powers, mostly US and China. And in 2016, say, about 80% of global investment by private firms in AI was by Alibaba, Amazon, Google, Facebook, Baidu, and a few other US and Chinese companies. So we're still a fair bit away from an arms racing dynamic outside of those dyads. And yeah, I mean, there's still some time to go, but again, in a future scenario, given that we've seen similar arms races in traditional military capabilities in South Asia, for instance, and notoriously in the nuclear space, that in the future, as these capabilities become more accessible and research and development into these technologies expand in other countries, that it's possible in the long run.
Okay, thank you. I'd like to move on to another area, and Trisha, just to kind of pick up on some points that you raised relating to non-state actors. And I think you hit on some important points in terms of the security and safety built into military systems directly. But I would also like to hear your thoughts in terms of non-state actors, aside from receiving a direct transfer from a state, the ability of non-state actors to actually make use and acquire lethal autonomous weapon systems on their own, either through their own production or through modifying and adapting existing military systems that they can acquire. And
so a lot of the component tech, as I mentioned, is fairly mundane. So something as simple as sensor fusion or computer vision is fully acquirable, even if you don't have like transfers of tech. And we've seen in a lot of cases of these terrorist and insurgent groups, they attract a lot of educated folks, people who have a background in computer engineering and related fields. And so, yes, more likely at present than a state transfer of critical capability, if they should develop it in the future of autonomous weapons, it is far more likely that they Frankenstein together something that works. It's not perfect. It still would be dangerous. A single unit is enough to wreak havoc and achieve any sort of political goals such as that.
All right, thanks. And so, I think a follow-on question then is,
if you permit, I will add.
Yeah, Vadim, go ahead, and then we'll have a follow-up question for Trisha.
Thank you. First of all, we can see that nowadays those drones, armed drones, were used by terrorists some years before they were used by regular armies. So those components can be easily found and purchased, and actually there are supermarkets for components which might be used by terrorists for their needs, and it will continue happen. Commercially produced drones are much cheaper. Sometimes they are more advanced. We can see that US Marines use Chinese drones for their military missions. There were orders by MOD prohibiting use of Chinese commercial drones. So which means that commercial industry provides everything terrorists need nowadays. And it will continue, I suppose, as far as commercial companies much faster. They need the market, they produce cheap components. And what is also noticeable at present, for the last decade probably, many civil companies engage in military projects, not only in the United States or China, but all over the world, including Russia. So it's another trend which is also worrying, I would say. Military consume civil brains and civil expertise for military purposes and make the globe less safe, I would say.
All right, thank you, Vadim. You, in a way, preempted the question I was going to ask, which is really to follow up on, how do we actually, design an approach that's effective against this, as we all know, a very standard tool for dealing with proliferation to non-state actors are export controls, and these tend to focus on objects, components, and whatnot. In light of the commercialization of a lot of this technology and what's available, can export controls be effective to address concerns that you see in terms of acquisition of laws, technology by non-state actors? So Trisha, I wanted to pose this to you first. If you want to react.
Sure. So yes, a lot of this tech is easily, not very easy, but fairly easily developable. And so an export control regime, the starting point would be to not just have like-minded countries on it, but everybody on it. Because if one actor says, okay, we will have a more robust export control regime, we will only export to trusted partners, partners that have the necessary regulatory frameworks and other safeguards in place, there's always going to be another actor that's willing to step in and fill that vacuum and provide cheaper alternatives with fewer strings attached. And so really all hands on deck, everybody needs to be part of the dialogue approach is very important.
Okay, thank you. I think we're coming near the end of this first segment. Just wanted to ask either panelist if there are any final remarks that you wish to make at this time. Okay, so yeah, thank you very much for your presentations, which have been quite broad and diverse. If I might kind of make some very quick kind of observations at this stage. I think it's kind of quite apparent that some of the implications in terms of the peace and security impacts of autonomous weapons are still a bit unclear, if I might say so. That there is an aspect that's quite context specific, but also looking at particular military capabilities that could be acquired, and perhaps this subject requires its own quite dedicated study, more than we can sort of accomplish in simply one hour together, just because I think that there is a real need to have a great deal of precision in the conversation as well, in terms of what it is that we mean by an autonomous weapon in particular. Just looking at some of the reactions that have been coming up as we've gone along. And so I think it's sort of sensible that the GG itself has not pronounced itself so directly on these questions, sort of in light of these complexities, but it does sort of point to an area where certainly more study is needed, and more deeper and focused engagement by the expert community as well. And so I think that this panel was very useful in highlighting some of these emerging points that could benefit from further study and review and clarification moving forward. So thank you very much for that. I think I would like to transition now directly into the next panel. And so for the final bit of our time today, we will be looking at operational considerations. And so there is already agreement within the GGE that human judgment is essential in order to ensure that the potential use of weapon systems based on emerging technology in the area of laws is in compliance with international law, and in particular IHL. And so for many, that means that such weapons must be subject to meaningful human control, and that this can be assured at the international level through various measures implemented at different part of a weapon's targeting cycle, and that these controls will also depend on certain contextual factors. The GGE has made considerable progress in understanding what some of these contextual factors could be. And so one such approach that we've heard is based on understanding the relationship between the nature of the primary effect of a weapon, the nature and complexity of the operational environment in which a weapon is normally expected to be used, and the various properties of human-machine interaction that are available throughout the targeting cycle. And so our next segment, I hope that we can sort of explore in each of these different contextual factors that could be helpful in for the GG as it moves to develop recommendations on the normative and operational framework. And so we have again two presenters to help lead our discussion. First, I would like to ask Paul Scharre, Director of the Center for New American Security, to deliver a presentation. Paul, you have the floor.
Hi, thanks very much. I'm glad to be here. Thanks for having me as part of this dialogue. Very excited for this discussion. I want to start off by making just some very introductory comments about how we might think about the human element in use of force operations. First, I guess I'll point out that there has been a widespread consensus among discussions in the GGE about the importance of the human element. It's been reflected in a number of GGE documents. Individual actors, as part of these discussions, seem to have very different phrases for how people use the bumper sticker, if you will, seems to remain contested. You folks that like terms like meaningful human control is one term. That is certainly contested. There are others that like different kinds of formulations, appropriate human judgment, necessary human involvement. This sort of formulation of blank, human blank seems to be common, and you can mix and match kind of your necessary adjectives here. But all of this revolves around the idea that in some level, humans are needed going forward. And I think this is an important starting position because while it's important to consider the state of the technology today and what it can do, I think a very valuable conversation to have is, if we had all the technology in the world, what role would we want humans to play in warfare and why? And so even if the technology could perform a whole variety of tasks, what task would still require uniquely human judgment? And I think that starts to get at the core of this issue about the human element in war and what is needed. I think that's a great place to focus the conversation and to try to move the ball forward to get a better understanding of what type of human involvement is required. Now, I'll suggest that there's at least two ways, there might be more, but I'll suggest at least two ways of approaching this question of what tasks require uniquely human judgment. One way is to look at current practice and to say, okay, what is the current practice that is used by nations using technologically advanced capabilities, and what does that tell us, at least about, at a minimum, how things work today? And one of the things that we can find by looking at current practice is that there are a number of interesting features about the way that humans are connected to use of force decisions today. So in some cases, of course, this human involvement is very direct. It's not very heavily mediated by technology. You might have an infantry soldier on the battlefield who looks down their rifle and sees an enemy and pulls the trigger. It could be very direct. There are other cases where it is mediated by technology, that human involvement in the use of force, and there may be multiple layers of the process being distributed. So that could be that the person is relying upon sensors, that they're getting information about the enemy, about the battlefield that they're relying upon. In some cases, those sensors are processing information. So it may not be just a video feed the person's looking at where they can see themselves. It might be, say, a radar that's processing some information about a potential target or other objects in the area. And then a person is relying on that information and that data processing to then help build contextual understanding about what's going on. In some cases, human decision-making is distributed. So there are humans involved in a use of force decision, but it may be a variety of people. You may have some people drawing up a target list based on intelligence information ahead of a strike. Then you have other people that approve the target list, then people who approve an attack. Then that's passed down to targeters who are uploading this target list into a database. You have a commander saying, okay, go ahead and launch this. You have someone else who's pushing the button to launch a missile. And so while humans are involved, there may not be one single individual who is sort of involved in the process in its entirety or sees the whole picture. Another interesting component worth mentioning when we think about information that humans have is, while there are some settings where people have real-time, very clear information about what's happening, this is particularly the case for drones today, where drones afford the ability for humans to sort of look at the target in real time and see what's going on the ground. There are many situations where that's not the case, and it's not been the case for a very, very long time in warfare. So at least since the invention of the catapult, there have been situations where people are launching attacks and they don't have real-time information about what's going on right at the instance where the weapon is going to strike. It doesn't mean that the attack is unlawful. They may have enough information to make a determination about the lawfulness of the attack. It doesn't mean that they're seeing in real time that particular area. It's also been the case, really since the first time someone threw a rocket through at someone else in anger, that that most projectiles, once launched, cannot be recalled. It's only been very recently that we have network-enabled projectiles that are smart munitions that have some connectivity back to the operator, that a person can actually recall them after they've been launched. But that's certainly not been the norm in warfare. That is an advantage. That's an advantage from both a military effectiveness standpoint and clearly a humanitarian standpoint. If you have the ability to call off an attack after it's already been launched, but that's certainly not required. It's not been required, and there are many attacks that are carried out today where you might even have significant time delays. In the case of something like a cruise missile, you might have a very lengthy time delay between when an attack is launched and it's not recallable, and then when the attack is carried out. So I think those are important to keep in mind, because I often hear definitions raised about what the human element ought to be that would impose constraints that go far above and beyond existing current practice. That would require constraints like, people have perfect information in real time about what's going on in the vicinity of the attack, that the attack is recallable right up until the moment is carried out. Those things would be ideal. They'd be advantageous. They're not realistic. That's not how warfare has been conducted in some cases for millennia, and that's certainly not how it's conducted in many cases today. So I think that's one area to approach the problem, is to look at current practice and say, what is done? What is the role of the human element? I think the other way to look at this is to come from a legal perspective and say, okay, what is the what are the minimum necessary requirements under IHL for human involvement? Now, I think that's an open question and worthy of a lot of debate and discussion. I'll start with a couple propositions here, all of which I'd say are contestable, right? And I think people could argue, well, I'm not so sure about those. But let me try to at least lay out maybe the skeleton of an argument here. I would start with the proposition that international humanitarian law applies to people and places obligations on humans. And those obligations for compliance with international humanitarian law cannot be passed to machines. That is not necessarily a position one could take. I think one could argue, that those positions could be delegated to machines. But I think that there's sound reason to sort of make an argument that compliance with IHL is a uniquely human responsibility, and ensuring the lawfulness of their actions is something that military personnel are required to do under IHL. Now, if that's true, then that suggests that the principles of distinction, proportionality, precautions and attack, etc., that it's humans who have to be making these decisions to ensure IHL compliance. It's humans that have to be able to say, okay, yes, this attack is lawful and it meets these certain criteria. I think that suggests some degree of then human involvement to be able to make an informed decision along those lines. So the human must have sufficient information about the target or targets, about the weapon, the environment in which it's being employed, the context for the attack, in order to make a determination that that particular attack is lawful. That requires some degree of information the human needs to have about all of those factors. Similarly, in order for that attack to be sort of a meaningful, if you will, decision, that attack itself also must be bounded in time, in space, in the targets it's going after, and the means of attack, in order for that to be a sort of meaningful decision that a human is making. Presumably, there might be some conditions under which that attack is no longer lawful. And so those boundary conditions, whatever they may be, are important. Now, how much information a person needs, what those bounds ought to be, I think is, open for debate and unclear. But I would suggest that at least establishes some minimum necessary standard for human involvement, and maybe a way to get some purchase on the problem. So let me go ahead and stop there, and I look forward to the discussion. Thanks so much.
Okay, thank you, Paul. And, we'll turn now to Netta Goussac, Associate Senior Researcher at SIPRI, to deliver a presentation. Netta.
Thanks, Michael, and thank you to Trisha and to Vadim and to Paul for their interventions just now, and to the UNODA and to UNIDIA for convening this webinar series and for inviting me to take part, whether it's in my current capacity as a researcher with the Stockholm International Peace Research Institute or in my former capacity with the International Committee of the Red Cross. I'm always very thankful for the opportunity to support the work of the GGE, including tonight. I wanted to take this opportunity to share my reflections on the topic and on the excellent guiding questions that were provided by the organizers. And I'll be drawing specifically on research that was conducted by SIPRI and the ICRC in 2019, and which is explained and summarized in a report that we published in June. I'll put a link to the report in the chat. But before I dive in, and given the questions that have been coming up in the chat, I just wanted to clarify that I agree completely with Paul about the term human control, human element, human judgment, and how they can be used to mean the same thing or different things interchangeably. I will sometimes use the term human control tonight, but I don't mean to use it with any prejudice as to the kinds of debates that are going on in the GGE. I'm just using it as a marker, but of course a number of other labels could be applied and have been applied. And I'll also use the term autonomous weapon systems and when I use that term, I'm referring to weapon systems that can select and apply force to targets without human intervention. And again, I don't mean to use that term in order to designate any kind of acceptable or unacceptable systems, lawful or unlawful systems, or even indicate any scope to the GGE's mandate. I just use it as a sort of shorthand. Now, given the short time available, I just really wanted to focus on three key broad questions that I drew from the guiding questions that the organizers shared. And they are, firstly, what are the military operational drivers for having human control, having human involvement in the development and use of autonomous weapons? What can we learn from existing military practice with respect to weapons that are capable of autonomously selecting and applying force to targets? And why does this matter? What can we do with this information? So turning to the first question, the why, what are the operational drivers for some kind of human involvement or control over autonomous weapon systems? Now, a core characteristic of autonomous weapons is that they are triggered by their environment, meaning that the user doesn't know or choose the specific target, the timing, or the location of the resulting application of force. And as Paul has pointed out, this is not entirely unique for the user not to have real-time awareness of the environment in which force will be applied, but it's the combination of being triggered by the environment that really makes autonomous weapon systems unique. And this process by which these weapons function creates or introduces an unpredictability in their consequences. And this unpredictability, sometimes it might be acceptable and sometimes not, but it definitely raises challenges for military command and control, and of course also for risks for civilians and challenges for compliance with IHL, as Paul mentioned, as well as quite fundamental ethical concerns. But for today, given the topic of this webinar, I'll be focusing on the challenges in the military operational space. And first up, it's really important to note that militaries normally leverage technology to exert more control over the use of force, not less. And there are three really important reasons for this: ethos, safety, and efficiency. When it comes to ethos, and this has been pointed out on a number of occasions in the GGE, from an operational standpoint, the military doesn't see utility in weapon systems over which there can be no control. Having some control over all weapon systems and all applications of force is a very important part of military ethos. And so in pursuing autonomy, I guess you could say the objective is not to lose control, but to change it. The second main military driver is safety. All technologies have their limits, no matter how complex, no matter how so-called sophisticated the system might be. And these technological limits can challenge safety and reliability of military operations. So whether it's because systems fail or because they are tricked or defeated, the result is that the safety of fighters and the mission can be put at risk. And thirdly, efficiency. Human control or human involvement is not only needed to overcome limitations in technology and to ensure safety in unexpected circumstances, but it's also needed in order to make sure that the actions of individual autonomous weapon systems in specific attacks operate in line with the military strategy and the context, not to mention, of course, the legal obligations, which are set a minimum standard. So that's the why. Why should we focus on the human element when it comes to autonomous weapon systems? Secondly, what can we learn from existing practice? And so, as Paul mentioned, it's important to remember that militaries have been using weapon systems that create distance between the user and the application of force for a long time. And indeed, militaries have been using autonomous weapon systems, or at least in the way that I've conceptualized it today, for a long time, albeit for highly constrained tasks and in quite narrow circumstances. This has been happening for decades. And so the question about control is not a new challenge, and all existing autonomous weapon systems, whether they're defensive and offensive, they operate right now under some form of human control. So from a military standpoint, that kind of unpredictability in consequences that I spoke about that results from a weapon system that's triggered by its environment is reduced or compensated through what SIPRI and the ICRC have identified as 3 key measures: strict control measures on the weapon system itself, control over the environment of use, and human-machine interaction. Those are the 3 key methods that we've identified by looking at existing practice. So I'll explain each of them in a little bit more detail. So by measures on the weapon system itself, what we're talking about is measures that restrict the parameters of the weapon's operation. So with existing systems, a human determines where, when, and for how long the system can operate, and Paul explained this as well. The types of targets that force can be applied to, and under what conditions the weapon can apply force autonomously. Typically, an autonomous weapon today would only be able to apply force to predefined material targets, not human targets, in situations where the time frame for reaction or the targeting cycle from identification through to application of force is very short and may be deemed to be too short for human capabilities, like in air defense or defense systems against missiles, etc. Secondly, the second element of control is that over the environment. And here we can think about how existing air defense systems use the system itself as well as radar and radio communications to indicate an exclusion zone in order to exclude civilian aircraft, and in the case of maritime systems, civilian vessels from the area of operation for the duration of its activation. So this kind of physical exclusion is an example of control over the environment. So, and the third element is that of human-machine interaction. So here, existing autonomous weapon systems are operated under direct human supervision at the moment. Existing air defense systems that can identify and select and apply force to targets autonomously do allow human supervisors to exert different degrees of control depending on the operational circumstances. Active protection systems, as another example, which are designed to protect vehicles against incoming missiles or rockets, can function autonomously, but also allow the human operator to deactivate the system if the environment or the circumstances make its use problematic. Similarly, robotic entry weapons are operated at the moment under direct human control. So these are examples of the kind of human-machine interaction that is demanded by autonomous weapon, is applied in autonomous weapon system use today. So we've looked at the why human involvement and human control is important, whether it's because of the military ethos, military safety, or military efficiency. And we've looked at the what, like what kind of measures are taken by militaries today to control existing weapon systems, control over parameters, environment, and human-machine interaction. So why does this matter? How should these elements be taken into account or quantified, as the guiding questions say? And another way of saying is, what is the perfect mix of these measures? And it's a fundamental problem that really exists with autonomous weapon systems. How do you calibrate the interaction between the human users? And I say that in the plural because, as Paul pointed out, there may be multiple people involved in the use of an autonomous weapon system. How do you calibrate these interactions between the users and the system in order to ensure that its use remains effective from an operational point of view and also from a legal and ethical point of view? And our research showed that really a technical solution, or like a quantitative solution to this problem, it's a significant challenge to identify that. We tested these ideas in an expert workshop in June last year and examined some realistic scenarios of autonomous weapons use. And what we concluded was that there was no one-size-fits-all combination of control measures for every situation that could be mandated for every situation. It really depends on the context. And by context, I mean the type of tasks that are involved, the type of target, the kinds of sensors that are being used, the duration of the operation. I also mean the characteristics of the environment, how predictable it is, how observable it is, how controllable it is. And also the characteristics of the users. What are the physical and cognitive abilities of the humans that are involved in using the autonomous weapon system? How much do they understand about the system? How is control distributed amongst people? So there are many elements that need to be taken into consideration in determining how to get to that perfect mix of human involvement or human control in any given situation. But there is one guiding principle or implicit principle that could be applied in place of a kind of quantitative or technological approach. And that is this. In any given scenario, what are the measures that can ensure that the user has sufficient understanding of the weapon system and its environment of use, and is able to take sufficient precautions to ensure that its use and consequences in a specific attack comply with the law, are ethically acceptable, and operationally effective and safe. To put it in another way, how can these measures ensure that the user has reasonable certainty about the effects of the autonomous weapon system in its specific environment of use, and that the user can exercise the kind of judgment and intent or agency in the use of force that is demanded by the law and by ethical considerations? So to conclude, most foreseeable circumstances of autonomous weapons use, all three types of measures that I've outlined, measures of control over the weapon's parameters, over the environment of use, and over human-machine interaction, all three types of measures will be needed from an operational perspective, from a military perspective, but also from a legal and ethical perspective. The importance of each type of control measure will vary according to context. Where one type of control is inadequate or challenging to implement in the situation, others may rise in prominence. But the critical issue is that the control measures have to allow the user to have reasonable certainty about the effects and exercise judgment or intent and agency over the use of force. Now, today I focused about what in 2018 the GGE report called the use phase, the phase in which an autonomous weapon system is being used in a specific attack. But this kind of analysis, this three-pronged approach to human control or human involvement, it can inform the kinds of measures that would need to be implemented by states during all stages, whether through the design of an autonomous weapon system, the development of research and development of the system, how it's tested, how it's deployed, how it's procured, how its legality is reviewed. These kinds of national measures are really critical, whether it's measures relating to the testing and review of autonomous weapons by states who are either developing them themselves or procuring them, whether it's measures relating to how militaries are being trained to use autonomous weapon systems and the kind of doctrine that applies to their employment. These are really critical measures. And I think it's really useful to talk about these measures in particular because these measures of control in particular, because it provides us a way of removing ourselves from the technology and focusing on the human element. And that's the element that's most familiar to states and to militaries as well. And I think that that's the kind of approach that to me would seem to be helpful when talking about limits on autonomous weapons, whether in the form of new rules, standards, best practice. this kind of normative development needs to focus on this human element rather than the technological fixes. For the reasons I've explained, it's extremely difficult to identify a technological solution to these questions. And also, in order to ensure that the solutions that are developed by the GGE remain relevant and practical and adaptable to future technological developments and are not stuck in our current understandings of autonomous weapons. I'll leave it there.
Okay, thank you very much, Netta. It's very, I think, rich presentation, but also, I think, very comprehensive in terms of the kind of setting out some very kind of concrete ideas for solutions and possible approaches. And so I've sort of immediately kind of start off with trying to sort of understand, on the one hand, identified sort of, a broader general principle relating to, the human element, but looking sort of more deeply into these kind of three areas of controls and given kind of the complexity of the interrelationship. What do you see in terms of like elements that could be distilled? Is this going to be a very kind of complicated task of looking at each particular facet of each kind of situation, looking at each, for instance, type of an environment and the type of kind of weapon effects that can be had, and the kind of human-machine interaction that's kind of appropriate, and or how do you see that work going forward of sort of identifying what is sort of the necessary level of control?
Sorry, Michael, were you addressing that question to me or to Paul?
That was to you, Netta.
Oh, I'm sorry. Well, thank you for the question and for the opportunity to expand on what I've already said. I think that looking at these kind of control measures that I've mentioned, it does help in the discussion of the GGE, and I can give you a couple of examples. So when we talk about controls on weapon systems parameters, the types of targets, the duration of operation, etc., it's true that there's no one duration that would be acceptable in all situations. There's no one type of target that would be acceptable in every situation or should be restricted in every situation. But we could start to look at generalities like general restrictions on the types of targets against which autonomous weapons may be used. And in particular, I'm thinking of human targets and the kinds of legal, ethical, military concerns that are raised. We could also look at general constraints on a weapon's freedom of movement or the duration of operation, not in terms of specific time, but just merely the fact of having a limit on duration or having a limit on movement, that limit is set. And importantly, we could also look at requirements for deactivation or fail-safe mechanisms to ensure that these limits are effective in practice. When we think about controls over the environment, we could look at limits that aim to avoid or at least minimize the effects of autonomous weapons on civilians and other protected persons by making sure that they're only used in areas where risks to those protected persons or objects are minimized. So precluding their use in certain types of areas or having to exclude civilians from areas where autonomous weapon systems are operating. Again, that's a practice that's already done. And when it comes to human-machine interaction, we could think about limits that address the need for some kind of supervision over autonomous weapon systems or the ability to intervene in its operation in certain circumstances, what's called in the GGE parlance, human on the loop or human supervisory control. So I think that there are general restraints, constraints, limitations that can be drawn, and that indeed, if I had to say if they would concretize or reflect existing practice and kind of set that out as the kind of practice that we would want to see as the technology develops as well.
Okay, thank you very much. I think another kind of important aspect that kind of follows from that in terms of measures that states are to undertake at a national level. If you're looking at controls in each of these three areas, how does sort of a state or a military kind of demonstrate that systems that they are developing and employ do actually adhere to these sorts of limits, and how do you do that? Does that have to be done in sort of a design and testing evaluation stage, or what are the possibilities for providing that kind of assurance to others? So I appreciate your views on that, and also if Paul wants to come in on that as well. But Netta, if you have sort of an immediate reaction.
Yeah, thanks. I mean, I think the question about transparency is really important because, firstly, I would want to say transparency to whom? I think that even within the military, it's important that the users themselves are confident that the weapon system has been tested in order to be effective in the circumstances of use, that they understand how it works. And that's an important component of the kind of trust and reliability that from a military perspective you would expect would be needed. So transparency to one's own forces is the important first step. And then being able to demonstrate that externally is the second step. So I think when we talk about transparency, we need to look at it both from the sort of internal point of view, the transparency that the military needs to have of its own weapon systems, and then secondly, how to demonstrate that to others. I agree with your suggestions that the legal review process or the procurement process provides those opportunities. But I have to, like I said, I think the critical question is, how can the military satisfy itself of this and then go about satisfying others? I wonder, I mean, I give Paul the floor as well because I'm really interested in his views on that.
Okay, thank you, Netta. Paul, you want to come in here?
Thanks. Well, I think the point about clarity to users is a great one, and I completely agree. One of the incidents that I looked at early on when I started working on this issue was the 2003 fratricides that the U.S. Patriot system was involved in the early stages of the 2003 Iraq War. And in at least one of those cases, this one major contributing factor was this issue of a lack of transparency to the users about limitations of the system, that there was a known technical limitation that had come up in test and evaluation that had not been corrected or was just difficult to intrinsically correct, that the engineers understood in certain conditions the radar system, the Patriot air defense radar system, would misclassify a descending aircraft coming in to land at an airfield as a missile because of its flight trajectory. And that information was not conveyed to the operators during their training. And so when they actually ran into the situation in real life, they're not looking through, a set of binoculars or a telescope or something else to see there's an aircraft. They're relying on this information mediated through a machine that tells them there's a little indicator on their screen saying, oh, there's a missile coming in. So they think there's a missile, right? And, if they had maybe multiple sensors that they could deploy at this potential target to get better target ID and verification, that would, of course, be more advantageous. There are other potential safety measures like IFF, identify friend or foe, signals that should have been activated at the time and were not for reasons that are not entirely clear. But additionally, if they just had this information about the limitations of the system, then it's possible, we don't know for certain it's possible, they might not have fired in that instance. So I think this is a great point about clarity to the users. And I think it's a problem that's only going to become more challenging over time as these systems just become increasingly complex. We already have very, very complex electromechanical systems today that use computerized software where even the engineers at times may not fully understand what's going on, in particular because the operating environment is one that the testing will always imperfectly represent, right? So it's very different than other settings where you might have very complex systems, but you can achieve high safety standards because you can control the environment, and then you can maybe test its operation of this complex system in the real world day-to-day environment. So you get something like a nuclear power plant where safety is obviously very, very important. You know, they're operating in this environment day in and day out all the time. That's not really the case for militaries. It is for some types of military operations, say flying an aircraft, operating a submarine, operating an aircraft carrier. When you're getting into the combat situation where now sensors are detecting enemy targets, well, you'd actually don't get an opportunity to test that in a very realistic environment on a day-to-day basis. And in fact, if you were to go to the adversary and say, listen, we want to make sure that our sensors can accurately find you, right? So would you mind just go ahead and turning on your radars and lighting up your aircraft and your tanks for us? They're not going to do that, right? And so this is just an intrinsic challenge in this kind of space that presents all sorts of, kind of risks. So I think that this is challenging, and I think to the broader point that Netta made about transparency, voluntary transparency measures that states undertake and potential agreement among states to encourage these transparency measures, right, to build more confidence about what states are doing would be very, very helpful in this space to states just get more clarity about how they operate. One of the challenges, which is obvious, but it's worth just pointing out, one of the challenges here in this area is that it is not externally observable how the system's software is going to function and what it's doing. And more importantly, how the human element is interacting with it, which in and of itself, that human software of how the human interacts is going to depend upon training, culture, doctrine, other factors. So it's not as simple as, counting missiles, counting tanks, looking at something externally, and experts might be able to make some guesses about the characteristics of this weapon system. And so I think greater transparency by states about what they are doing, how they intend to employ the systems, how they operate them, is going to be essential going forward and will go a long way towards allaying fears, towards highlighting areas of concern where they might exist, and towards over time establishing some patterns of best practice. I think Netta's presentation laid out very well the sort of multifaceted concerns here, and in fact, it's not easy to kind of come up with some very simple, this is the yardstick that we should employ in all cases. Having been worked on this issue for over a decade now, initially inside the U.S. Defense Department, it would be very easy if there was just a single metric you could give weapons developers and say, look, your system can only operate for this amount of time, and it has to deactivate or come home, right? It can only operate inside this geographic bounds. The fact that probably depends quite a bit on context makes it more challenging, but also I think it makes it all the more important that states are transparent about what they're doing so we can begin to have these dialogues that then sort of flesh out what are the best practices over time, right? And you can have a debate, and states might say, well, I think that's problematic, right? Or outside actors might say, what are you doing here? How are you ensuring that this is compliant with international humanitarian law? And have those discussions.
Michael, I wonder if I could just add to the question, to what Paul said. Correct me if I'm wrong, Paul, but from what you're saying, it seems to me like there are real practical and security challenges associated with transparency. That kind of transparency might be hard to achieve in practice. And I wondered if like, what's your level of confidence on that? Because the reason I ask is that the question of transparency and the question of limits are linked, right? You can have, increased transparency, everyone puts their cards on the table, and you sort of see where the minimum, requirements are really around the world. Or some kind of limits are agreed at an international level in whatever form in order to inform the kinds of national practice that would then be shared and that states would be transparent about. So what's the link between these two? Do you think that transparency is achievable given the security concerns that exist and the complexity involved?
No, I think that's a great point. I think there are going to be limits on what countries are willing to share. So I would sort of encourage a greater transparency, right, and pushing countries in that direction. But I think particularly when you start getting into the technical details, there are going to be lots of things that countries aren't going to be willing to share, because as soon as you start outlining that, then you're also exposing what the system can't do, what its limitations are, what are countermeasures and ways to defeat it, right? So if you say, oh, well, it can only operate inside this geographic area. Okay, or only this time limit. Well, that's good for me to know. Now I know ways to maybe get around the system, to hide from it, to defeat it. Oh, it requires a communications link? What frequency does it operate on? Right? That would be good to know so that I could jam its communications link to render it less effective. What sensors does it use to detect these targets and at what ranges? Those are, I think, the details that countries are not going to want to get into for obvious reasons. And so I think there are going to be some very serious limits that you run into. Nevertheless, I would encourage, I think we could have some conversations that are better than nothing, right? And some opportunity for states to sort of raise questions and concerns, and maybe people come forward with whatever transparency they're comfortable with. In part because, I'll just say, having looked at one of the interesting phenomena that I've observed, sort of trying to dig deeper on weapon systems and peel back, the layer on a lot of systems, trying to figure out what's actually going on, is that there's often a little bit of overhype in the selling of weapon systems, right? So one of the phenomena that I discovered repeatedly is when you go to like the web page of the weapons manufacturer, there's a lot of like it's autonomous and it does autonomous this, and there's a lot of like, and they're why? Because they're trying to sell it, right? They're trying to sell it to militaries and show like look at all its advanced features and characteristics and the whole thing it does. And then oftentimes when I would be able to sit down in a closed room with the weapons developers and they'd say, all right, don't write this down, but like we'll tell you what it's doing. It was like a lot simpler in practice. And it was maybe not as snazzy as it looked at the advertising. And so I think that in many cases, having states at the state level be more transparent might help allay some fears. I will say that I often see this when I'll talk to defense persons who are very animated about what they're hearing other countries are doing. Oh, well, we got this news report of this autonomous thing and all these features. And I'll, say, well, I'm not so sure that that's true, right? But I think there is a risk, right? That fear of, oh, they're building the super scary autonomous thing, so we better do it ourselves, and we need to race to get ahead. Is that itself is a problematic dynamic. So even a little transparency might in some cases be advantageous, but I think you're right that there are going to be limits in how far countries are going to be willing to go here for sure.
Right. Yeah, thank you. What also strikes me as well is like, in other regimes, consultative mechanisms and that ability to have states directly kind of engage and ask questions to each other is quite important. Another tool is the ability to investigate when there are allegations of sort of wrongdoing, and I sort of wonder how those sorts of mechanisms could like translate into problems of autonomous weapons and what kind of access. It's not like you can go to a site and take a sample that indicates that something was done in a way that it should have, or there was a software glitch or whatever. It seems like if you are investigating an alleged use of a weapon that either malfunctioned or resulted in civilian deaths, you might need some other kind of access. Maybe you need to be able to talk to the manufacturer and the developer, or you need to have more robust access to the command and control to kind of identify that, and that might be an important consideration for a military, also to demonstrate that they did their own due diligence, undertook all the necessary precautions as well. How do you start to approach that with autonomous weapons? does it require kind of a different approach, or is it sort of not a useful area to attempt to get into? Is that another dimension of controls that we can kind of explore?
Netta, do you want to jump in here, or do you want me to?
Well, I'm happy to sort of reply very briefly. Like I said, I think that's a really good question. And to me, it seems like even though it's the moment of use that is really the crucible for discussing what kind of human involvement is needed from a military perspective, and importantly, from a legal and ethical perspective, because that's where all the legal and ethical rules and consequences lie. We can expand the analysis outwards to address both the design and development stage, and then the post-use stage, the question of assessing what has happened, where the force was applied, how, against what, whether a violation of IHL has taken place and who is responsible, whether that's an individual or a state. And the same kinds of measures that are useful for ensuring lawfulness, ensuring military efficiency and safety, ensuring ethical acceptability in the use stage will then be helpful in the post-use stage as well. Questions about, in particular, relating to the interaction between the user and the system, what the user knew about the environment, what the user knew about the system they were using, about the target of the attack. These are the kinds of questions that will be relevant for that kind of post-use assessment. And so the same kinds of measures, whether it's questions about the parameters of the system, questions about the environment of use, questions about the human-machine interaction, they'll be relevant at that stage as well.
Okay, thank you.
Thanks. I'll add just a few small things. I mean, I think one, I do think there's value in transparency, of course, ahead of time. I think if you're looking after the fact, when there are accidents, there's value in investigating accidents and pushing for investigation to try to uncover what went wrong. I think in practice, we've seen in other instances when there's an accident like a civilian airliner shoot down, even when humans are involved, that these investigations run up against the bounds of state sovereignty and how willing are states actually hold an honest investigation and be transparent about it and release information. I don't think that we're likely to get, at least in the near term, a very intrusive, independent verification regime, something like a sort of an IAEA for autonomous weapons. It's possible, I guess, it's something like that evolves over time, but I think it's not likely in the near term today. But international pressure on states to be more transparent, to conduct, investigations after the fact and release information, could be helpful in some settings, depending on, in particular, which state it is, right? States are probably more or less responsive to that kind of pressure and have, more or less responsive to sort of their reputational costs in doing so. But there's certainly value in pushing for those if there are incidents over time.
All right, thank you. One other area that I wanted to kind of explore a little deeper is this sort of question of ethics, and I know you've both touched upon it. As we're looking at different places, Paul, and thinking in terms of what you described as sort of this sort of distributed nature of decision making, and as machines autonomy kind of enters into this. How do you sort of build ethics into that? Where a human might be able to rely on their own judgment. How do we ensure that the decision-making process sort of retains that quality of sort of ethical judgment?
Netta, do you want to take this, or do you want to? Can we jump in? All right. I'll take this one then. So I think ensuring ethical behavior comes in a couple of ways here. One would be, I do think that there are ways that you can envision using the technology to help ensure more ethical behavior of the weapon system and its application. I don't think that looks like sort of building in an ethical governor so that the system itself is like weighing deontological reasoning or something. I think that's not really what we're talking about. I would compare it more to something like a self-driving car and a very simple function like automatic braking on a self-driving car. There are not settings that I'm aware of where you would normally want to run into intentionally the car in front of you and hit it. And so, building a very simple automated braking function on a car that senses the car in front of them and then applies the brake if the human is not able to do so in time to stop the car is one that's not involving ethical reasoning on behalf of the car, but results in more ethical behavior that's less likely to cause harm. And so I think you could envision similar types of functionality in weapons that might help ensure fail-safe behavior, perhaps add in greater time for humans to make decisions, perhaps avoid certain types of targets, and that all could be very advantageous and add in more ethical behavior. I think there's also really an essential element of human judgment here. That ethical reasoning is going to be the thing that humans are bringing to the table, in part not only because machines today are not really capable of doing that, but also because some of these things don't have clear answers, right? So there are principles in IHL involving things like proportionality, for example, that don't have clear quantifiable answers, right? Where it's going to depend upon human judgment about, well, what is proportional? How do we weigh military necessity against civilian harm in a particular attack? And preserving that space for humans to come in and to apply that ethical reasoning and ensuring that there's still the capacity for humans to do so is, I think, really important to maintain that going forward.
I agree with Paul, and in fact, the 2 points you made, Paul, reflect two different types of ethical or two different types of emphasis that could be applied to the ethical question, whether you're looking at ethics, the ethics of the consequences of the use of autonomous weapon systems or the effects of their use, or whether you're placing the emphasis more on the process by which decisions to use force are made. And both of those approaches to ethics, I think, are critical when looking at autonomous weapon systems. But in relation to consequences, I mean, there's a real limitation there, because what is an ethical consequence can really differ from situation to situation, as Paul mentioned. When looking at process, I think there is much more, to sink your teeth into when it comes to how to protect that human role, like noting that humans are the only moral agents, that machines don't have moral agency. How do you protect that ability for humans to make, to play their moral role in decisions to use force? And I think in practice, what that would require is, as Paul said, ensuring that there is space and time for the human to engage in the kind of reasoning that is needed in order to exercise moral agency effectively. And I think this question of ethics is a little bit linked to the question of accountability that you asked before, because, of course, an important part of this emphasis on ethics is the ability to ensure a kind of moral responsibility, moral accountability for the decisions that humans make. And anything that severs that kind of connection between the decision maker and the consequences of their decision can serve to undermine the ethical acceptability of the entire act. I think the same goes, so that's from an ethical perspective. I think the same can be said from a legal perspective. And if I can add to Paul's answer to the previous question, any element of an autonomous weapon system, any characteristic of the technology that undermines the ability of the military that uses it to be able to understand what happened would be concerning, because it would really make it difficult to comply with the legal and ethical obligations relating to ensuring responsibility and accountability for the use of force.
All right, thank you so much. So we are near the end of our time here. So I think the session has really been quite rich in terms of laying out very clearly some of the conceptual areas that are worth kind of further exploring, but also putting some very concrete ideas out there for consideration. So I want to thank both of you for that. Let's see, and just to note that there are relatively few direct questions put into the chat, so I think it's also testament to the clarity of your presentations as well. So thanks. I just want to invite our special guest, Ambassador Georginski, if he would like to come in at this stage with any observations on his part before we wrap up. The floor is yours.
Oh, thank you very much. And once again, 2 days in a row of really substantive, constructive discussions on exactly what we're discussing within the GG. A few things stand out as they have within the GG as well. And perhaps one kind of theme that arose from the first part was this aspect of reduced trust in this context, and how that fuels a possibility of a really increased complexity in and of itself. And then perhaps in the second part as well is this increased complexity because of the dependence on context, on how the context really changes how we need to approach this. What I think it was Paul kind of mentioned of what the sensors are giving any human in a given context. A missile is coming, and it points to the fact that we are dealing with autonomy of a weapon in a given context, but we're also dealing with what kind of information technology is given the humans to decide upon, and that's something that as well we really further points to the increased complexity. So this combination of reduced trust and increased complexity is a dangerous combination. On the other hand, I think that we have approached it within the GG over the past few years and found ways, and even whenever there is an obstacle that comes up to us, to go around it, or not rather go around it, but really to absorb it within the discussions of the work of the group of governmental experts. And it's interesting, this discussion at the end, especially of this perhaps duality between a need for transparency and the risk of sharing it. And it was pointed out that perhaps for security reasons, it is difficult to share details. However, it is interesting about this technology that it might be in the interest of a military to even share some aspects of how it is gone about testing a given weapon to even adversaries, because they understand that it is in their interest to avoid an unintended escalation in a given context. So that's an interesting element in this, but it's an important part of why we have this GG. And really, this has been a great conversation that has started with the technological possibilities of yesterday, that has continued today with the military incentives, if you will, but also the complexities and the inherent complexity of the element of trust. And as we move tomorrow to, well, how do we address it? And within especially this instrument of CCW, of IHL, that it is, of international humanitarian law, that allows us the flexibility and the language to address it. So once again, thanks to all 4 participants. Thank you, Michael, and thank you to UNIDIR and ODA to really providing a very good complementary, once again, a process, so that within the GG we can also reflect on it further as we move along. So once again, my gratitude to all, and thank you for inviting me to jump in at the end.
All right, great. And with that, we are right on time. I see Netta has supplied in the chat a link to the SIPRI ICRC report. I would recommend that to everyone who hasn't read it yet. And yes, please do return tomorrow. Unidir will be back in the host seat for the session on legal aspects. And so look forward to all of you rejoining us for the third and final webinar in this series, and wish a good day, afternoon, evening to everyone. Thank you so much for joining us. Goodbye.
Thank you. Bye-bye.